Welcome to the deep dive. Today, we're really getting into it.
We are.
We've got this document, the Generative AI Learning Roadmap 2025.pdf.
That's the one.
And we're going to try and pull out the key stuff, give you a fast track to understanding generative AI, maybe even getting hands-on.
Exactly. It's a dense roadmap, so our job is to filter it down, find the core knowledge you really need.
Because this field moves so fast.
It really does. So we'll cover the
Yeah.
big ideas, the math behind it, coding, the machine learning basics, all the essentials.
Okay, let's jump right in. Generative AI. What is it, fundamentally?
Right. So at its core, generative AI is about AI systems, systems using algorithms, neural networks.
Deep learning.
Okay.
Usual suspects.
Pretty much. And they use these to create new content, original stuff.
Like what kind of stuff?
Well, text, images, music, even computer code, content the AI actually invents.
So it's not just finding patterns, it's making things based on them.
Precisely. That's the breakthrough. They learn the deep structures in data so well they can synthesize completely new things that still fit the pattern.
And the roadmap highlights specific abilities.
Yeah, things like generating truly novel outputs, learning from feedback, getting better over time, adaptability, and scalability, handling bigger and bigger tasks.
And why is this blowing up right now? Why is 2025 such a focal point in this roadmap?
Well, the roadmap points to a huge shift. Generative AI isn't just in labs anymore.
Right, it's everywhere.
It's getting baked into consumer apps, tools businesses rely on. It's fundamentally changing how tasks get done, how innovation happens.
And the tech behind it.
The core idea, as the roadmap lays out, is identifying and replicating patterns. Using models like GANs, VAEs, transformers, those are the engines.
Okay, now the roadmap talks about designing these applications. What are the key principles there?
That's important, yeah, how to build these tools right. The roadmap mentions designing for generative variability, encouraging the AI to be creative, basically, diverse outputs, not just repeating itself. Then there's co-creation.
Humans and AI working together.
Exactly, like partners in the creative process. And of course, control and explainability are huge.
So you can guide it and understand why it made something.
Yes. Plus, human in the loop, recognizing we still need human oversight, human feedback in a lot of cases.
Makes sense. You need that check. The roadmap also makes a point of distinguishing generative AI from discriminative AI.
It does. That's a fundamental distinction. So generative AI, like we said, learns the underlying probability distribution of the data. Its goal is to generate new data points that look like the original data.
Like learning what cats look like to draw a new cat.
Exactly. It's focused on PXY, or just PX, the overall structure.
Okay, and discriminative.
Discriminative AI learns the boundary between different classes of data. It's about classifying existing data or predicting an output for a given input.
So, not drawing a cat, but telling you if a picture is a cat or a dog.
Precisely. It focuses on the conditional probability, PYX. What's the label Y given the input X?
Got it. One creates, one classifies. Can you give some real-world examples?
Sure. The roadmap has good ones. Generative AI powers things like, deepfakes, realistic image generation, writing assistants, music composition tools, creating synthetic data.
Okay.
Discriminative AI is behind stuff like spam filters.
Ah, classic example.
Facial recognition, credit scoring, medical diagnosis from scans, object detection in self-driving cars, identifying pedestrians, other cars.
That clears it up nicely. Now, the roadmap mentions hallucinations in generative models. Sounds worrying.
It's a really important concept. Because these models are inventing things based on learned patterns, they can sometimes generate outputs that seem plausible but are factually wrong.
Like making up facts.
Exactly. Or creating an image with details that don't make sense in reality. They might sound confident, look convincing, but be incorrect.
So verification is key.
Absolutely. That's why evaluation and human oversight are often critical, especially for important applications.
Okay, that gives us a good grounding in what generative AI actually is. So what's our main goal digging into this roadmap today?
The mission really is to give you a clear, structured look at the essential foundations, the building blocks from the roadmap.
Right.
We want to equip you with that solid base so you can explore further, understand the key concepts, and not get lost in the hype.
Fantastic. Let's move on then. The roadmap calls the next section the mathematical backbone. I start with math. Seems intimidating.
Well, it might seem that way, but the roadmap is right. Math is the language we use to describe and build these models.
You can't escape it.
Not really. Linear algebra, calculus, probability, statistics, They're fundamental, but the key is living them in the context of AI. That makes it much clearer why they matter.
Okay, let's break it down. Linear algebra first. What are the absolute must-knows?
All right, linear algebra is all about representing data. The roadmap points to vectors and
These
matrices.
arrays of numbers, right?
Yeah, essentially, yes. Organized arrays that let AI process images, text, whatever, numerically. Solving systems of linear equations is important too.
And matrix operations.
Crucial. Things like matrix multiplication are literally how calculations happen inside neural networks. That YWX plus B formula, that's matrix multiplication and addition right there.
Okay, what else?
Linear transformations, how data gets shifted and reshaped. Vector geometry. And then eigenvectors and eigenvalues.
Those sound complicated.
They can be, but they're important for things like dimensionality reduction, simplifying complex data using methods like PCA. Think of them as finding the main directions or patterns in your data. Generative models learn to play with these.
Wow, okay. Lots there. Where does the roadmap suggest looking for help with linear algebra?
It gives a few good pointers. Johns Hopkins has a Coursera course, Foundational Mathematics for AI. O'Reilly has linear algebra for machine learning.
More practical, maybe?
Yeah, focused on using it in Python. Then there's 3 Blue One Brown's Essence of Linear Algebra video series, great for intuition.
I've heard good things about that one.
It's excellent. Khan Academy, of course. And the Deep Learning book by Goodfellow and others has a solid theoretical section.
Plenty to choose from. Next up, calculus. How does that fit in?
Calculus is key for understanding how models learn, especially deep learning.
The optimization part.
Exactly. Learning is about adjusting the model's parameters to minimize errors. Calculus gives us the tools for that.
Like derivatives.
Yes, derivatives tell you the rate of change. They give you gradients, which show how tweaking a parameter affects the error. That guides the learning.
Right.
Then partial derivatives and gradients for functions with many inputs, optimization methods like gradient descent, the workhorse of AI training, and even integrals pop up in some probabilistic models.
So where do we learn calculus for AI?
The roadmap mentions deeplearning.ai's Calculus for Machine Learning and Data Science on Coursera. O'Reilly has a Calculus for Machine Learning intro, too.
Focused on optimization again.
Seems like it. And that Johns Hopkins Foundational Math course covers calculus, too.
Right, okay. Linear algebra for structure, calculus for change.
Yeah.
Now, probability and statistics. The uncertainty part.
You got it. Generative AI is fundamentally probabilistic. It learns the probability distribution of the data.
To know what's likely, what's unlikely in the data.
Precisely. And then it samples from that learned distribution to create new stuff. So understanding probability and stats is non-negotiable.
What concepts are key here?
Basic descriptive statistics, visualizing data, then probability theory itself, Bayes' theorem, is fundamental. Random variables, understanding different probability distributions like the normal or Gaussian distribution.
That one comes up everywhere.
It does. Also sampling, estimating parameters from data methods like MLE and MAP, and concepts like confidence intervals and hypothesis testing.
And resources for this.
DeepLearning.ai has a probability and statistics for machine learning and data science course. Johns Hopkins covers it. Khan Academy has a great general course.
Textbooks.
The roadmap suggests an Introduction to Statistical Learning, ISLR, a classic and practical statistics for data scientists.
Good recommendations. The roadmap also has a table, Table 1, connecting math concepts to AI models. Can you give an example or two?
Yeah, that table's useful. For linear algebra, it stresses vectors and matrices are used in all neural network models, GANs, VAEs, transformers. It's how data and weights are stored.
Okay.
For calculus, it points out derivatives and gradients are essential for backpropagation, the algorithm used to train almost all deep generative models.
Right, the learning mechanism.
Exactly. And for probability and stats, it highlights probability distributions being core to modeling data structure and defining latent spaces in models like VAEs and diffusion models. It makes the why much clearer.
That's super helpful, seeing the direct link. Okay, let's shift gears from the math to the tools. Programming for generative AI starts with Python, obviously.
No surprise there. Python is, as the roadmap says, the lingua franca of AI.
Why Python?
Well, it's relatively simple to learn, has amazing libraries, and a huge active community. If you want to do generative AI, you pretty much need Python.
What specific Python skills should people focus on?
The roadmap lists the basics. Syntax, data structures lists, dictionaries are vital for data handling loops, functions for reusable code, understanding object-oriented programming, or OOP, for bigger projects, and knowing how to use modules and packages.
Leveraging other people's code.
Right. Don't reinvent the wheel.
Where can folks learn Python for this?
The roadmap suggests the Geeks for Geeks Python tutorial, very comprehensive. Coursera has Python for data science and machine learning. And platforms like DataQuest offer interactive, data-focused learning.
Beyond Python itself, what about the core libraries? The roadmap emphasizes a few.
Yes, these are the power tools. First, NumPy. Absolutely fundamental for numerical work, especially with arrays, matrices, multidimensional data, critical for performance.
The foundation.
Pretty much. Then Pandas, which builds on NumPy, gives you data frames like powerful spreadsheets and code for data analysis, cleaning, loading, transforming data.
Essential for getting data ready.
Totally. And then Matplotlib and Seaborn for visualization. You need to see your data, see how training is going, see what your model is producing.
Can't work blind. Okay, now the big ones. Deep learning frameworks. TensorFlow, PyTorch, JAX. Quick rundown.
Okay, TensorFlow from Google is a mature end-to-end ecosystem. Has the Keras API, which is quite user-friendly. Also has tools like TensorFlow Probability, TensorFlow Generative, and TensorFlow Hub for pre-trained models.
Widely used.
Very. Then PyTorch from Facebook's AI research, FAIR. It's gained huge traction, especially in research.
Why is that?
It feels more Pythonic to many, has dynamic computation graphs, which can make debugging easier. Its ecosystem for generative models, GANs, transformers, diffusion is really strong, partly thanks to great Hugging Face support.
Okay, interesting. And JAX.
JX is also from Google. It's newer, focused on high-performance numerical computing. It feels like NumPy, but with superpowers. Automatic differentiation, JI2 compilation for speed, easy vectorization, and parallelization.
So more for cutting-edge stuff or heavy lifting.
Often, yeah. It has libraries like Flax for neural nets and Optax for optimizers built on top of it.
So how do you choose? Which one should someone starting in 2025 learn?
Good question. The roadmap suggests it depends on the project, community, and just personal taste. But it does lean towards PyTorch as a strong starting point for 2025.
Because of research and Hugging Face?
Yeah, its prevalence there and the vast resources available make it very attractive. But knowing TensorFlow is still valuable, and JAX is definitely gaining ground for performance-critical work.
And they aren't totally separate worlds.
Not entirely. Crucially, the Hugging Face Transformers library provides a layer of interoperability. You can often use models across different frameworks with it.
That's good to know. The roadmap also mentions ecosystem awareness. What's that about?
It's realizing that learning a framework isn't just code syntax, it's entering its whole world.
Meaning?
Knowing how to find and use pre-trained models, using specialized toolkits like Hugging Face Transformers or diffusers, which are built on these frameworks, connecting with the community, following the research trends.
And tools like Git.
Absolutely. Proficiency with Git for version control and knowing how to use platforms where models are shared, like Hugging Face Hub, is essential for being productive. It's about leveraging the collective effort.
Makes total sense.
Yeah.
The whole environment. Okay, next section. Machine learning fundamentals. Why is this important if we're focused on generative AI?
Because generative AI is a part of machine learning. It's in branch, maybe an advanced one, but still ML. Understanding the core concepts gives you the context.
You need the foundations.
Exactly. You need to understand how these models learn in general, how they're evaluated, how they compare to other AI approaches.
So what are the core ML concepts the roadmap covers? Supervised, unsupervised, reinforcement learning.
Yep, the main paradigm. Supervised learning is learning from labeled data input-output pairs.
Like classifying images with labels.
Right. In generative AI, the discriminator in a GAN is a supervised learner, learning to classify real versus fake.
Okay, unsupervised.
That's learning from unlabeled data, finding patterns, structure. Many generative models, like VAEs or some GANs, learn the data distribution this way. Clustering, dimensionality reduction also fall here.
Reinforcement learning. Learning by trial and error.
Essentially, yes. An agent interacts with an environment, gets rewards or penalties, learns a policy. While not core to all generative models, it's used in things like RLHF reinforcement learning from human feedback.
For fine-tuning language models.
Exactly, to make their outputs align better with what humans prefer.
Interesting. The roadmap also specifically mentions self-supervised learning. What is that?
That's a really important one, kind of bridging supervised and unsupervised. The idea is you take unlabeled data and automatically create labels from the data itself.
Oh.
A classic example is language modeling, predicting the next word in a sentence. The sentence itself provides the label for the prediction task.
So you don't need humans to label everything.
Right. This allows models like GPT to pre-train on massive amounts of raw text, learning incredibly rich representations. It's fundamental to modern large generative models. The roadmap notes its importance, even mentioning specific courses covering it.
Gotcha. Where does the roadmap point for learning these ML fundamentals?
It suggests the MITx course, Machine Learning with Python, Andrew Ng's popular Coursera Machine Learning specialization,
A classic.
definitely, and the Geeks for Geeks Machine Learning tutorial for a broad overview.
Okay. And finally, within ML fundamentals, the roadmap talks about the machine learning workflow, the overall process.
Yes, the standard pipeline for building pretty much any ML model, including generative ones. It's a structured approach.
What steps?
Starts with data collection, getting the right data, then data pre-processing, cleaning, transforming, normalizing it. Huge step.
Garbage in, garbage out.
Always.
Yeah.
Then choosing a model, selecting the right architecture, like a GAN or VAE or transformer. Then model training, feeding data, adjusting weights, using a loss function, optimizer, all that.
The core learning part.
Right. Then model evaluation, seeing how well it performs using metrics, both quantitative, like FID or perplexity, and qualitative, just looking at the output.
Is it actually good?
Exactly. Then parameter tuning or hyperparameter optimization, fiddling with settings to improve performance. And finally, deployment, if you're putting it into production.
Understanding that whole cycle is key.
Absolutely. It's how you go from idea to working generative model.
Okay, wow. We have covered a ton of ground from this roadmap. Just to quickly recap for everyone.
Good idea.
We started with defining generative AI, how it differs from discriminative AI. Then we dug into the essential math, linear algebra, calculus, probability, and stats.
The backbone.
Then the practical side, Python programming, key libraries like NumPy, Pandas, visualization tools, and the big deep learning frameworks, TensorFlow, PyTorch, GAX.
And their ecosystems.
Right. And finally, we covered the core machine learning fundamentals, supervised, unsupervised reinforcement, and that important self-supervised learning piece, plus the overall ML workflow.
And it's crucial to see how all these pieces connect, as roadmap stresses. Understanding one helps you understand the others. They build on each other.
Definitely. It's all interconnected.
Yeah.
So the roadmap really encourages you, the listener, to explore these areas, use the resources mentioned, and start building that foundation.
It's the only way to really grasp the more advanced stuff later on.
Absolutely. So maybe a final thought to leave you with.
Yeah.
As you listen to all this, which of these foundational areas, the math, the coding, the ML concepts, which one felt most interesting or maybe most intuitive to you?
That's a good question.
Because that might be the perfect thread to pull on first as you dive deeper into this world and thinking bigger. What kind of new, novel content are you most curious or excited to see AI generate in the future?